Hello everyone! Today I would like to review basics of BGP configuration and some verification commands. But before we continue, I would like to ask you to subscribe to my channel with notification bell on, and please show your support by hitting like button. So let's do it. So how to configure BGP? There are a couple steps and I will talk about them. First step, you need to initialize the BGP process with the command router BGP autonomous system number. Then second step is optional. At this step you can statically define BGP router ID with the command BGP router ID and then use your router ID number. The best practice is to define BGP router ID statically. If there is no statically defined BGP router ID, then the dynamic router ID allocation logic will use the highest IP address of any app loopback interfaces at the BGP router ID. If there are no loopback interfaces configured, then the highest IP address of any app interfaces becomes the router ID during BGP process initialization. When the router ID changes, then all BGP sessions reset and need to be re-established. Step number 3. This step identifies the IP address and autonomous system number of the BGP neighbor with the BGP router configuration command neighbor IP address. Then you use remote autonomous system and autonomous system number. So this is the autonomous system number of remote or neighbor router, and this is IP address of neighboring router. In the BGP packet, the source IP address is the IP address of the outbound interface. When the router receives the BGP packet, it compares the source IP address of the packet to the IP address configured for that neighbor in the neighbor table. If they don't match, the packet can be associated with the neighbor and discarded. By default, EOS activates the IPv4 address family. The BGP router configuration command no BGP default IPv4 unicast disables the automatic activation of IPv4 AFI, and the following steps are required. Step number 4, initialization of the address family with the BGP router configuration command address family AFI SAFI, where AFI can be either IPv4 or IPv6 and SAFI can be either unicast or multicast. Step number 5. At this step, address family for the BGP neighbor needs to be activated with the BGP address family configuration command neighbor IP address activate, where IP address is the IP address of the neighbor. And on EOS and EOS XE, the default SAFI for the IPv4 and IPv6 address families is unicast and it is optional. And let's review some additional commands. And first one is BGP Aggregate Address. If you want to do route summarization, use the BGP address family configuration command aggregate address and then your summary route with network and subnet mask, and then two keywords summary only or as set, or both of them if you want. Summary only suppresses all the more specific routes of an aggregate address from being advertised, and keyword as set combines all the attributes of the original prefixes into the aggregate prefixes. It keeps the BGP path information history with this keyword. And next one, default route advertisement. It can be done in two ways. First one, with the command default information originate, it will advertise default route to neighbors, and the second one, you can advertise default route to only specific neighbor with command neighbor IP address with IP address of neighbor and default originate. And let's review some BGP verification commands. If you want to see the BGP topology database, use the following command show BGP AFI SAFI, where AFI can be either IPv4 or IPv6 and SAFI can be unicast or multicast. And then you can filter output with then adding the network at the end of your command to see only information for that network. To display routes that were not inserted into the IP routing table and the reason why they were not inserted, use the following command: show BGP AFI SAFI RIP failure. To display the memory used by the various BGP databases, BGP activity statistics, and the list of BGP neighbors, use the following command: show BGP AFI SAFI summary. To display details about each neighbor, and this command can be modified by adding the neighbor IP address at the end, use the following command: show BGP AFI SAFI neighbors. And to monitor the routes received from and advertised to a particular neighbor, use the following command: show BGP AFI SAFI neighbors, then IP address of the neighbor, and then you have some keywords: received routes, routes, advertised routes. If you use received routes, it displays all received routes, both accepted and rejected from the specified neighbor. But it shows routes before the inbound policy has been applied. If you use routes, it displays all routes that are received and accepted after the inbound policy has been applied. And advertised routes, as you understand, the routes which were advertised to the neighbor. So this is network which I'm going to use for example. We have 3 routers, R1, R2, R3. R1 is Autonomous System 100, R2 200, and R3 300. And we have 2 links between R1, R2, and 2 links between R1, R3, and each router has loopback interfaces with subnets. So I'm going to do summary for these subnets. I'm going to see how they advertise. I'm going to try also to configure default route on R2 and advertise that route into router R1 or R3 as well. So let's do it. So this is network 4 configuration. I already configured IP addresses, loopback interfaces, so I can start BGP configuration. But first let's verify. Enable show IP interface brief. All interfaces up and configure it. Router R2. All interfaces up and configured. Only connected routes, local, and here as well. So let's do configuration for BGP. Router BGP 100, this is Autonomous System 100 for router R1. BGP router ID 111. And our neighbor 10.12.02, remote AS 200, this is router R2, Autonomous System 200, and second interface or second link is 66. And let's do router R3, neighbor 10.13.03, remote IS, and autonomous system for router R3 is 300, and second link 66. And we need to advertise network 192.168.1.0 mask 255.255.255.224, and second one 32. Look back one. As you can see, mask is 27. Let's go to router R2. BGP 200, BGP router ID 2222, and here I'm going to disable automatic exchange of IPv4 address family prefixes. So this I'm going to do with the command no BGP default, and here we go, we have IPv4. Okay, and our neighbors remote, neighbor 10.12.0.1 remote IS 100 and second interface 65 or second link. And the third one is for R3 10.23.0.3 remote IS 300. I don't have option to configure network to advertise. This I need to do under address family configuration mode. So I need to go address family, IPv4 unicast, and here I have this option, network 192.168.2.0 mask 255.255.255.224, and second one 32. Okay, do show BGP summary, show IP, show BGP summary, BGP summary, and I don't have any neighbors, IP BGP neighbors. Show BGP IPv4 unicast neighbors. I don't have it because if I use address family configuration, I need to activate neighbors. Router BGP 200, address family IPv4 unicast, and here need to do neighbor 10.12.0.1 activate, and second one 65 activate, and the last one 23.0.3 show IP BGP neighbors. Now I have my neighbors. For example, this is neighbor 10.12.0.1 router ID, and we have hold time, keep alive, which is keep alive, hold time is 3 times keep alive, and we can do also show BGP IPv4 unicast summary. From here we can see sessions. So this is our neighbor 1 with router ID 111, and this is neighbor 3 router R3, but I haven't configured yet, so there is no information. And here you can see router identifier for this router, local autonomous system number, BGP table version, and how much memory some networks or paths take. So let's do router R3 then. Router BGP 300, BGP router ID 333, neighbor 10.13.0.1 remote IS 100, and the second one for router R1 65, and the last one for router R2 neighbor 10.23.0.2 remote IS 200. And we need to advertise our networks 192.168.3.0 mask 255.255.255.224, and second one is 32. Okay, let's verify. If we have our routes, show IP route BGP, still nothing. Show BGP IPv4 unicast summary. Everything is good. Let's check now. Still nothing. Let's check this one. Show IP route. And we have only from router R1. So what can be the problem? We have from router R2 and R3. Let's hope we have already here now. Show IP route BGP. Okay, now everything is good. So I have two routes to loopback interfaces on router R1 and two loopback one on two loopback interfaces on router R2. As you can see, I can do summary, and I will do summary aggregation, address aggregation for this and for this network and for loopback interfaces on router R3 BGP. And you can see our routes. This one for subnet 192.168.1.0 next hop. This is the best route through next hop 10.13.0.1, or it goes this way, just straight to R1. This route goes through router R2, and this one is not good. And here you can see where it starts, the pass, AS pass met parameter, which one is starting from 100. 192.168.1.0.27. These are three paths to get to this network, and you can see this one is the best. The AS pass this option, and you can see this goes directly from R1, and this one goes through R2. So let's do aggregation. Conft router BGP 100 aggregate address 192.168.1.0 and aggregate mask 255.255.255.192. Let's go to router R2. Conft router BGP 200 aggregate address we need to do in I forgot address family IPv4 unicast aggregate address 192.168.2.0 255.255.255.192, and the last one router R3 conft router BGP 300 aggregate address 192.168.30 255.255.255.192. So when we do aggregate address, it advertises the aggregated route in addition to the original component network prefixes. So let's see, show IP route. Let's do BGP. And as you can see, we have our aggregated route and we have two original prefixes. So show IP BGP 192.168.1.0.26, and as you can see, it shows that this is aggregated by router Autonomous System 100 or router R1, and it has metric atomic aggregate, which shows that it was aggregated, and so these aggregated routes, they act like new routes with a shorter prefix length. So to remove these original prefixes, we need to change our configuration, and we need to do summary only when we do aggregation. So let's do it summary only here, summary only here, and on R3 router BGP 300 summary only. Let's see what we have now. Show IP route BGP. Still, let's check on this one to show IP route. BGP. And if we go and do show IP BGP, you can see that these original prefixes, they are suppressed by this command, and they are not advertised to show IP route BGP. So now you can see that we have now only summarized routes. They were suppressed, and for this router we have also suppressed routes for 192.168.2.0 and 232 subnets. And if we go and check now this show IP BGP 192.168.1.0.26, we still have atomic aggregate, and we have 3 routes coming from R2 and 2 from R1. And if we disable interfaces, conf tg0 0 shut, interface g01 shut, and on this one interface g02 shut, interface g03 shut, and do the same command again, show IP BGP 192.168.1.0.26. We have this route coming from router R2 aggregated by router 100, and now let's remove this aggregation. Router BGP 100 and check. Let's check now. So IP route BGP. So I removed, I have this the beginning now, and I want to do it here. Aggregate address 192.168.1.0 mask 255.255.255.224. I'm sorry, 192.192, and I don't need the mask. Summary only. And let's do again. Let's wait. Yes, so it takes some time. Now Let's do show IP BGP 192.168.10.26, and now you can see that this route is coming from autonomous system 200. It says aggregated by 200 router ID 222, but it happens because aggregated routes act like new BGP routes with a shorter prefix lengths. So like they are new BGP routes from router R2. To change this, we can add option keyword as set router BGP 200, and then we have this option. So I need to do it under other address family IPv4 unicast. Then we need to do keyword as set, generate as set pass information. So it will include also previous pass information as set. And let's see on R3. Let's do the same. And now you can see that we have it is originated from 100 but aggregated 200, and we have full AS pass for this route. So when we do that, it includes also AS pass from the previous, from before aggregation, and some other like MED or BGP communities, they are also included in the BGP advertisement if we do this as set. Then the last what I wanted to show is configuration of default route. Let's do it on R2, and we need to do neighbor. I want to advertise default route only to R1. I can use command neighbor 10.12.01, and here we have keyword default originate, and it does not necessarily have to have this default route on itself. It will advertise it. So let's wait and see. Show IP route BGP. Let's wait. And let's add one more 65-second link. Now let's check again, and now you can see that we have default route which points to router R2 10.12.02. And let's review. This is everything I wanted to show about configuration, basic configuration of BGP, and now let's do some verification commands. Show IP BGP. So as you remember this command, you can see routes BGP database with all routes, and you can do also show BGP IPv4 unicast. To do like this, you will see the same information, and if you do summary, you will see sessions, you will see how much memory it takes, and all your neighbors with versions, autonomous system numbers, messages sent and received, and up down time and states. And last one is also you can do it show IP BGP summary. It is the same. So the last one more command, show BGP IPv4 unicast neighbors, and you will see detailed information for each neighbor. Let's see, I want to do like this section, include. I can see my neighbors, 1, 2, 3, and 4, 2 links per each. And in this command you can see detailed information per each neighbor. So this is a router with ID 222 and all information about this router. And one more command, if you add some keywords, so this is 10.12.02, and we can check, for example, received routes received. We need to enable software configuration router R2. Let's do just routes. So you can see route which were received from router R2. So these are routes received from router R2 after inbound policy applied. And from router, this is information from router R3 also, because this R3 sent to R2, R2 sent to R1 because these two links are disabled. And we also can check advertised routes. And then this you can see that we advertise these subnets, routes, and whatever advertised by this router. So this is everything I wanted to show you today. Thank you for your attention. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.